Hello, my name is Miklos Nadas, and I work for the City of Cleveland. And today we will be discussing simplifying data management using the Cityworks API and Python. I'm going to go over our agenda, and very first we're going to go over the project description, and that is the bulk importing of inspections into Cityworks. And a little bit of background, we had an inspector for the Department of Streets going out and inspecting and inventorying all of our guardrails. And we use Survey 123 for this initial inspection and inventory. The Survey 123 Esri application was tied to our internal SDE geodatabases, so the data was being brought right in. Now, the problem is that we like to keep all of our work history information in Cityworks. So we wanted to bring these initial inspections and photos into Cityworks, but how do we import these 3,000 guardrails from Survey 123 into Cityworks? And the solution that we came up with was using Python and the Cityworks API. So following through with the agenda, I'm going to go over a little bit about Python and Jupyter, go over who I am, the City of Cleveland, and then I'm going to go into the Cityworks at the City of Cleveland. And the best way I've decided to describe this is actually looking at the database and looking at the number of users, the number of types of work activities, the amount of work activities, directly querying from the database. And then we're going to go into the Cityworks API and the documentation, how to download, how to install it, just briefly. And then we're going to go redo that exact same queries, but using the Cityworks API for the number of users and then number and types of work activities. And finally, we're going to actually look at the Cityworks API and Python to, first off, we're going to manually create an inspection, and then we're going to dissect what we just did to create smaller API components and combine everything to bulk upload these inspections. And then I'm going to give some closing thoughts and moving forward. The very first thing you might notice is that I'm not using a PowerPoint. And instead, I decided that it'd be a lot more informative if I did everything directly in Python. And Python is a programming language that is pretty simple to use. One of the reasons I started learning Python is because Esri does a lot of their automation in their software using Python as well. So there are multiple ways to run Python, and such as ArcGIS Pro directly through idle and ArcMap. One of the other ways that we can run it is through this thing called Jupyter and using a Jupyter notebook. The positive benefit of Jupyter is that we can actually have an interactive session. So as soon as I do something within Jupyter, it will automatically show up and we can see the results instantly. So to continue on with my introduction, this is my LinkedIn profile. Miklos Nadas. I am a GISP for a few years now. I work as a GIS and Cityworks administrator at the City of Cleveland, graduated from the University of Akron in a degree of GIS, a master's of GIS and geography, and I have over a decade of work experience using multiple GIS platforms, and I've worked in multiple different industries. And so this just kind of shows you how easy it is and how interactive Jupyter can be. So next we're going to switch over to looking at the City of Cleveland. And as you can see, I can instantly display a logo of the City of Cleveland. So one of the things I thought might be interesting to show about the City of Cleveland is actually looking at a map, because if you're at Cityworks, you probably have used a map before and have some interest in it. And so what we're doing is we're going to connect to an ArcGIS Online, my ArcGIS Online account, and then we're going to map a point of the City of Cleveland right here. And the nice thing about Jupyter is that it just shows up right there in the browser, and it's an actually interactive web map. So if you're doing spatial analysis, this could be a very easy way for you to get some results almost instantly. And then just to show how interactive it is, I'm going to add the Cleveland boundaries so we can zoom in a little bit and show that, hey, this is where the City of Cleveland is located, and this is our jurisdiction. Finally, I want to do a brief look at the population of Cleveland, and we're using some GIS block groups, and if you're familiar with those. And so from these block groups, I kind of already did a pre-processing because it's a lot of information, and I imported these into ArcGIS Online. And we have within this, we already have, if it's within the city of Cleveland, filter. So we don't have to do a lot of spatial analysis. We can literally just put a very basic query on it that if it's within the city of Cleveland, let's give me a summary of the population of 2012. And as you can see, the population of the city of Cleveland, according to 2012, is about 400,000 people. I did this all using something called Pandas, which is one of the libraries I highly recommend using. Next, we want to go into Cityworks at Cleveland. And I thought an innovative way to do this would be to actually read the database to see what is going on with the city of Cleveland. And so we're going to connect to the city of Cleveland using a different Python library. And this connection string is going to allow us to directly connect and query it for different information, such as how many domains are within the city of Cleveland. The answer is 9. And these are all the different domains and departments that we currently have accessing it. We've recently added 311 and the Mayor's Action Committee, along with our airports this past year. And so Cityworks at the City of Cleveland is always expanding, always evolving, and always improving. And so 9 domains is a lot to manage, and let's just see how many employees we have. And so now if we query this database, we see that the number of active employees is about 2,700 individuals of active Cityworks users who are creating work orders and inspections and service requests. Similarly, we're going to do another SQL of looking at the number of work order templates, service request templates, and inspection templates. And as you can see, we have about 478 service request templates, 76 inspection templates, and over 1,000, almost 1,200 work order templates. Now, based off of this test instance, let's see how much work activity we have. So we have work activity dating back to about 2003. These were probably historically imported. And then we have about 500,000 service requests, about 200,000 inspections, and about a little over 1 million work orders. So the next thing that I wanted to go over is actually the Cityworks API. Each time you install Cityworks and one of your installations, you actually have this link to this API documentation. The API documentation has a lot of useful information as to how to send and receive requests and actually get information so that rather than querying the database directly, we can actually query using the API and Python. The next thing is that if you wanted to get the latest version of Python, you find the version of Cityworks that you have installed, and you would go through and download the SDK. Within the SDK is a Python folder with the appropriate libraries for you to be able to connect to your Cityworks instance. And finally, I'm not going to do this because I've already done it. You would just run within, the way I installed it was I used a command prompt and I installed it using Python, this install command right here, and you can do something similar. So a couple of the Cityworks libraries that are used that I import is, first off, this is the library that gets downloaded with Cityworks. And then I make all of my API calls through requests and JSON. So I use these two to get the token and the rest for actually making the individual calls. So I write 2 basic functions for most of my Cityworks scripts. The first one is that of just converting the Python dictionary to JSON. And so what this will do is whenever we want to send parameters to a URL request, this will take those parameters, convert it nicely, and apply a token so it can authenticate for us each time rather than us having to log in and enter our username, password, and this just makes it a little bit simpler. The next function is that of just making the request. And so when we submit a URL with the appropriate parameters, it can send this request to that URL and get a response. One of these responses can be of any of these values, such as the status. And as we can see here, a 0 indicates that it's an OK status. So we're going to connect to our base URL for our test instance. And the very first thing we're going to do is get the token. using the API. And so you can see that the token has been stored in this variable, and it will be used for all of our parameters whenever we make an API request. So if we wanted to get the number of employees, all we'd have to do is come back to this API documentation, and I'm working with AMS, not PLL, and we're looking at the employee API, and I'd like to look at all employees, and we can see that here's the request parameters, and this is the example request query. So I know that if I send this URL with this include inactive parameter, it will give back the number of employees. So if I run this, what we'll see is that we have the number of active Cityworks employees or users, and it's about 2,370. And then we actually have this URL. So if I click on this URL, this is basically the return that we shall see is based off of all of our employees and all of the data returned from that we can dissect, get the unique names, get their login names, and we can actually see at the very bottom is the status of 0, saying that it was able to return something properly. So, and so this is the basic idea of what an API is. You're submitting a URL with some information, and Cityworks is sending something back. So once again, to redo the work order templates, we're going to do something very similar as we did before, but we're going to be using the API. And so in this case, I've already done the legwork. I've done some research as to this is the URL we're going to call. This is the is active. So we only want the active work orders, templates, service request templates, and inspection templates. And we'll compare them to what we got from the database in SQL. So you can see that we have about 75 that are active, whereas the database just gave back all work order templates. So it gives you a little bit more information, and it's a little bit more intuitive, so you don't have to write these complex SQL queries, and you can find the parameters that are applicable to you. So now that we've dove into the API and the request calls a little bit, the next step is we wanted to go back to the actual problem. So the problem was we have about 3,000 guardrail inspections on survey 123 that we want to bring into Cityworks. And so the very first step I would do is I would go into Cityworks and I would create an inspection on my own to see what are the steps that we have to do. So the very first step that I'm going to do is I am going to select a guardrail that we have inspected. So this guardrail looks nice. And I am going to create an inspection from it by sending it back to the Cityworks server all manually. And so now when I click on inspections, it automatically shows it's a guardrail. We're going to create an asset photo inspection. I'm going to click create. And so now we have created an inspection. I'm going to update that I inspected this. I am going to update the date as well. And then I can see, and then I'm going to add an attachment of a guardrail photo to this item. So you can see this. Finally, I'm going to save this inspection and close it. So you can see there are multiple steps within just creating one manually, and doing this 3,000 times can be time consuming, finding the right GIS asset. And we'd rather do it all programmatically so we can quickly and easily finish it. So the very first step was to create a Cityworks inspection. So I did a little bit of digging either through the SQL database or through the API calls to figure out what inspection template was this DOS asset photo inspection template. And we figured out the ID was 70 and the entity type was guardrails, once again doing a little bit of digging. And so we figured out from the API documentation that we can look at up here is that if we wanted to create an inspection, you would just find the inspection, you would find what you're trying to do, which in this case is create. We can look at the request parameters. In this case, there are 2 requests that are, or parameters that are required. the entity type, and the inspection template ID. And if we wanted a little bit more information, here's the request query of the URL you're going to create and the data that can be within it. So we know that the template and the entity type is required, so we're going to add that into our parameters. We're going to create the parameters from that first function, and then we're going to make the request as the second function. So you can see that this has created an inspection for us. It's not connected to the GIS because we haven't done that yet, but that will be coming up in a second. The next step that we did was we updated this the inspection. And so I want to update it to today's date. And I want to get the inspector's ID. Once again, I did this through a little bit of digging to get the inspector's ID. And then I run the direct parameters and I make the update. A status response of 0 means that it worked successfully. So if we go back into the this inspection and I refresh it, what's going to happen is you can see that it's been updated to have the inspection date of today and inspected by Ronas. The next thing we're going to do is we're going to add an entity to connect to the GIS. And the way we're going to do this is I've already figured out what the asset ID is. We know the inspection ID because we just created it, and the entity type is we know we're working with only guardrails. So when we run these parameters, it's going to give us another status of 0. And when I refresh this inspection, it no longer appears saying that the map it's unmapped, but instead we have a new inspection, and we can highlight it, and you can see that it's the same asset ID 53254 as within our Jupyter notebook. The next is we want to attach a list of photos. And in this case, we actually have a couple photos we want to attach. And this is just to show you that, hey, sometimes you can have one asset with multiple photos. And so I created a dictionary here, an array here that basically has 2 photos, one of a guardrail and one of Jimi Hendrix, because why not? And it's going to loop through this array and it's going to create a new image for each of these files. And it's going to upload those images. And the only parameter we need is the inspection ID. So here you can see that the status is 0, 0. And so it's going to go through and attach 2 images to this inspection. And as you can see, here's our guardrail photo, and here's Jimi Hendrix. So we can say that that successfully worked as indicated by the status response. And the final thing that we did was we closed the inspection. So no one else can modify it. And so once we refresh that one more time, we can see that the status is closed, inspection, and everything looks as it was supposed to be. So while this was a very basic, not too much information being ported over, we can add as many parameters as the API can hold, and we can look at all of this information. So it's great that we did it for one inspection, but now we want to do it for multiple. And this is going back to the library of Pandas within Python. And so what I did in the backend was I created 2 Excel tables, and one that was just pretty much the feature class, and I added their asset IDs and the asset collection date from survey 123. If we had different inspectors for each asset, we could have added those inspector IDs if that was in survey 123. If we had other information, custom information, we could add that as other columns within this Excel file that can be used as parameters for uploading into the Cityworks update of that inspection. And then for my own simplicity, rather than trying to create one table and doing a bunch of querying in the backend, is I created another table with the SDE global ID as a unique linking field to the original table, just so we can have a table of photos. In this case, you can see that each asset has 1 photo except for this asset 34510, which has 2 photos. So now that we have these 2 Excel files that are being read by Pandas, what we can do is we can combine all of that information, and we can loop through the data frames or the Excel files row by row, and we can go through and do some very basic error logging, such as, is there an asset ID? If there is an asset ID, continue. If not, skip it. And then it will go through, and we're just going to piece together those 5 parts that we did. We're going to create an inspection. We are going to update that inspection based off of the information within the data frame, which in this case is the asset collection date. Luckily, we only had one inspector, so it wasn't a big deal of trying to get that information, but it would have been a simple line change. We are then going to connect to an entity based off of the asset ID within the GIS. And then we're going to check the data frame of the photos, and we're going to do a basic query within Pandas that will return only the rows with the appropriate unique field, which in this case is the SDE global ID. It's going to loop through all of these photos, and it's going to attach each one of those photos to the appropriate inspection. And then finally, we are going to close the inspection. And then for logging purposes, I'm just going to print the complete inspection ID. And for our own personal benefit, I'm going to print the inspection URL. So let's give this a whirl. And as you can see, it's just printing out all of this information, gives me the asset ID, gives me the inspection ID. And so something that would have taken me a couple minutes each time, it literally just did 4 inspections in less than a minute. So to give an example, there's this guardrail, there's the ID of the inspection. It was inspected on March 4th of 2020. It has the guardrail photo attached, and we can highlight this within the Cityworks map. And so you can see that this inspection is tied to this guardrail. And so now whenever anyone in Cityworks will look at this guardrail, they'll have an easily accessible photo to that guardrail. Similarly, I'm going to show you the one with the 2 photos. And in this case, we have the 2 photos attached, and it's not a problem. Python did that very nicely and very easily. So that is how we were able to make this solution of bringing in all the Survey 123 data into Cityworks without a problem. So just a couple of final thoughts on all this. And my first step is always to try to complete the process manually. If I can create the inspections manually using the mouse, it gives me a better idea of how to split it up and what are all the steps required to programmatically do it within Python. And just because a computer needs to be explicitly told exactly what to do, or it's going to go haywire. The other question I always ask is, will I run this multiple times? In this case, yes, I will update 3,000 inspections. So this is not something I wanted to do manually, definitely a road for automation. And usually a script is supposed to save time. So if you're trying to develop a fully robust, error-proof, user-proof script that's supposed to work every single time with no problems, how much time is that going to take? How cost-effective is it going to be? How much time are you actually going to save? In this case, I was able to develop a very basic script, and that was exactly what we needed to upload 3,000 guardrail inspections into Cityworks. Another thing that really helps me out is being extremely familiar with the data. So knowing the database goes in, seeing the feature class tables, being able to export those from the attachment tables, and just understanding how all of these different pieces and components work really allowed me to easily and efficiently create this script. Technology is always improving. And so one of the things is, as soon as you think that you needed a custom code, next thing you know, Cityworks is going to develop something where you can do this all non-programmatically. And I always recommend you develop and test on a non-production instance of Cityworks. So just a little bit more about Cityworks at Cleveland and how we're moving forward. We are currently planning on upgrading to 15.6.4. We are going to hopefully add another domain within the next few months. We have another implementation on an existing domain, so a lot of very exciting things happening in the next couple months. And from my end, I want to start automating a quality assurance testing for future upgrades and enhancements. And basically what this means is that when Azteca releases a new version of Cityworks, we can run some automated quality assurance testing to make sure that all of our custom configurations and everything is still working as it should. And one thing that I'm also would like to use is start something called Postman, and it just hopefully going to be very similar to Jupyter, where it allows me to easily test the API calls from Cityworks into and then bringing those back into Python just to see what works and what doesn't work. And I think that will help me out with our automation here. So here's a GitHub link to the Jupyter Notebook for anyone who's interested, and my contact information with my email address for anyone who has any questions or any other information. Well, thank you very much for watching, and I hope you all have a great conference.